For over 50 years, scientists believed they had the ultimate rulebook of the universe. It perfectly explained everything from the stars in the sky to the atoms in your body. But recently, a tiny, invisible particle just tore that rulebook to pieces. Physicists are currently in a state of absolute panic and excitement. We might be on the verge of discovering a brand new, fundamental force of nature. A secret realm of physics that has been hiding in plain sight. Welcome to Arthur's Physics. Today, we are diving into the Muon g-2 anomaly, the experiment that just broke our understanding of reality. To understand this mystery, we have to look at the standard model of particle physics. Think of it as the ultimate Lego set of the universe. It lists all the fundamental building blocks of reality, like electrons, quarks, and photons, and explains how they interact. For decades, the standard model has been undefeated. Every time scientists tested it, the math was flawless. Until they started looking closely at a particle called the muon. What is a muon? Imagine an electron, but about 200 times heavier and highly unstable. Muons are created when cosmic rays from deep space crash into Earth's atmosphere. They only exist for a couple of microseconds before decaying and vanishing. But scientists discovered something strange about them. Like electrons, muons have an internal magnetic compass. When you put a muon inside a magnetic field, it spins and wobbles, almost like a spinning top on a table. The standard model of physics is incredibly precise. It calculated exactly how fast this muon should wobble. So, scientists at Fermilab in America built a massive 50-foot magnetic ring. They fired billions of muons into this ring at nearly the speed of light to measure their wobble. When the results came back, the scientific world stopped. The muons were wobbling too fast. The math didn't match. It wasn't a mistake. They ran the experiment again and again with unimaginable precision. The muons were defying the known laws of physics. But why? Why would a particle suddenly ignore the rules of the universe? In quantum mechanics, empty space isn't actually empty. It is a bubbling, boiling ocean called the quantum foam, where ghost particles pop into and out of existence in a trillionth of a second. As the muon travels through this foam, it bumps into these ghost particles, which affects its wobble. The standard model accounted for every single particle we know about. So, if the muon is wobbling faster than it should, it means it is bumping into something else. Something we don't know about. This means there are unknown particles hiding in the dark corners of the universe. It could be the mysterious dark matter that holds galaxies together, or it could be a completely undiscovered fifth fundamental force of nature. For the first time in a generation, the rulebook of physics is broken, and that is exactly how science moves forward. We are standing on the edge of a new era of discovery, ready to rewrite the universe. But here's the twist. In June 2025, Fermilab published its final measurement, the most precise ever made. And at the same time, theorists finished a new calculation of what the standard model actually predicts, using a method called lattice QCD. This time, the prediction and the measurement agreed. The anomaly vanished. So, no fifth force. Not yet. But the mystery didn't disappear. It only moved. Those new calculations clash with 4 decades of older collider data, and nobody yet knows which side is wrong. The muon was telling us the truth all along. We just weren't sure what we were comparing it to. Do you think scientists will finally discover a new force of nature, or is there an error in our math? Let me know your thoughts down in the comments. If you're watching this on Facebook, make sure to hit that follow button and share this video to spread the knowledge. And if you're on YouTube, hit subscribe and ring the bell so you never miss a journey into the unknown. Keep questioning everything. I'll see you in the next video, right here on Arthur's Physics.